I will go through some very easy questions first before I actually move on to harder questions. The exam types question, right, are below. Question 4, question 5, question 6, question 7. These are exam types questions, right? And the one with the star beside is usually the question. It's a special type of question that you need to pay focus to. Okay. I also always tell my students to focus on the type of questions instead of doing 40 questions of the same kind. Yes, you have to repeat a certain amount of questions before you master a particular subtopic, but doesn't mean that you do because you see, you get what I mean. You must understand that repeating questions is good, but if you know that topic already, it's better for you to improve on other types of questions, because types of questions can be unlimited. You cannot predict what type of question can appear. So the best thing for you to do is to improve to improve in the sense where you increase your knowledge bank in terms of types of question once you have mastered the individual topics by doing questions. All right. So as I move on, I'll tell you more. Okay, so we'll try to do A first. Okay, these are quite simple. Like question 1 and question 2 is quite simple, so I'll do it quite fast. If anything you don't understand, just ask me. I have 3 to the power of -2 over 5 to the power of -4. Okay, so what do you think of when you have a power? Okay, first thing I think of is a power of negative. That's all I'm thinking of. Okay, when you have power of negative, remember I told you, when you have power of negative, the negative will change to 1 over. So this thing will change to 1 over, then you write back 3 to the power of 2. Don't forget, don't write the negative here. Don't write this negative. This negative will disappear, okay? In a bracket, divided by, okay, this 5 to the power of -4 will become 1 over 5 to the power of 4. Okay, the negative will become 1 over, as I keep repeating and repeating. I think you're bored listening already, but it's good for you lah. Okay, then this case, okay, if I'm a person who is following Brian's advice, or I've compiled the mistakes, I know that when you're dividing a fraction, I remember myself writing it down in that when I'm dividing a fraction, what do I do is that when I'm dividing a fraction, I do 2 steps. I change the division to times and I flip the fraction. So what I do is I take 1 over 3 square. Instead of division now, this division now, fraction means division, I times. What is the condition? Can you change this division to times? Is that you must flip the fraction that you're dividing with, which is now I have 5 over 4, or 5 to the power of 4 divided by 1. I flip the fraction. Okay, so what you get is 5 to the power of 4 over 3 squared. 3 squared is actually 9 because 3 times 3. 3 squared basically means you times 3. Means 3 times 3, 2 times. 3 multiply itself 2 times, which is 3 times 3. Not 3 times 2, but 3 times 3. So 3 times 3 is 9. As I said, I'm repeating a lot of simple things because I'm not sure what level you are. So it's better for me to teach everything instead of assuming that you know certain things. Okay, 5 to the power of 4 divided by 9. 5 to the power of 4, I'm not going to calculate it. You can leave it in this form. It depends on what the question is asking. All right. So that is A. We move on to B. Write down your answers, because I'm going to erase after I solve the question. All right. So I'm expecting you to actually work with me so that we can move on together. All right. So square root of 16 minus 168 to the power of 0. Straight away I spot one thing. 168 to the power of 0. Straight away I know is to the power of 1. Why? Because I told myself already, I learned before in the theorem that anything to the power of 0 will give me 1, except 0 to the power of 0. So I know that this will give me 1, which means I have square root of 16 minus 1, which gives me square root 15. Okay, this is called the square root. Square root of 15 is the answer. We will do more of this in certs, chapter certs in 4.2. All right, but I think I'll include video for 4.3 first. And then for C, what can I spot is there's a power of 3 to the power of 2 and then 7 to the power of -1. So what do you do is that you change 7 to the power of -1. As usual, 3 to the power of 2 divided by, when you have a negative power, what I told you is you convert it to 1 over. So it's 1 over 7 to the power of 1. 7 to the power of 1, I can just write it as 7. All right? Because anything to the power of 1 will give you that thing itself. Okay? Maybe I'll add one principle for you here. A to the power of 1 is equals to A. Okay? this may be a new principle I can add for you. A new not principle, a new idea of indices. Okay, a new content of indices. So what you get is when you're dividing a fraction, as I said, when you're dividing a fraction, you just basically divide here, you change to times, you flip the fraction. Instead of 1/7, you write 7/1 or 7. Okay, 1 is 7, don't forget that. Which will give you 3 squared is 9. As I said, 3 times 3 times 7 will give you 63. Okay, this is C, nothing special. You move on to D. D is 3 to the power of -2 over 4 to the power of half. Okay, this question you have two ways to do it. Either you can actually change this to you convert this to 1/3 squared, convert this to the negative power. Remember the negative power thing. Either you do that first, or you multiply the power inside first. Why can I multiply the power inside first? Why? Because of the theorem whereby it says a over b to the power of n is equal to the a power of n over b to the power of n. Okay, when you're dividing two things and this thing is under the same power, you can do this. Okay, under the same power, don't forget. Okay, because this bracket belongs to n. Okay, this power n belongs to this bracket, of a divided by b. So I can multiply the power inside. All right. I'll write one note down for you that people always tend to make mistake in it, which is a plus b. Just now was multiply, right? This now was division. A over b power of n equals to a power n over b power n. What if you have plus power of n? This is not equals to a power n plus b power n. Okay. Why? Why do you say it's not equal? It's very simple, because I did not learn a theorem about this. Okay. So if you're not sure, don't use it. You get what I mean? Don't use it. A simple way to prove it is to prove it to yourself lah. Is 2 to the power of 3 power of 2 equals to 2 to the power of 2 plus 3 to the power of 2. You check left hand side. What is left hand side? Left hand side will give you what? Left hand side will give you 2 plus 3 will give you 5. 5 squared will give you 25. What's the right hand? Right hand side will give you 2 squared, which is 4, plus 3 squared, which is 9, will give you 13. Or it shows that it is not equals to. I prove to myself. I use simple maths, simple ideas, simple. This is a very important concept also, okay? Whenever you meet any complex things, right, you're not sure of, you want to test yourself, you can use values to test. Okay? Once it's not correct, you know that this theorem doesn't work. So this is wrong. The above theorem is wrong. Okay? So this is wrong, okay? Remember, a plus b to the power of n is not equals to a power of n plus b power n. Only when inside is multiplication or division, you can put the power inside, times the power inside, basically. If it is not, you don't do it. Okay. So this one will give me. There are a few methods to do this question. I will straight away times the power first. So what I'll get is, I'll get 3 to the power of -2 times 1/2. Why? Okay, 3 to the power of -2 to the power of half. According to this formula, divided by 4 to the power of half. And you must understand, to the power of half is actually equals to square root a. Okay, square root, because it's actually square root is actually root to the power of 2. Root, I mean root is second root, the second root of a. All right. Yeah. So what you do now is you simplify. When you have a power next to each other, don't forget this is theorem number 3, if I'm not mistaken. Yeah. If you have power side by side, what you do is you multiply them. So when you multiply -2 with half, use your calculator. If you do not know what to do about it, all right. You get -1 divided by 4 to the power of half. You can either use your calculator, or if you are good in math, you can straight away convert this to square root 4. I can think of it as square root 4, as I told you. Of half to the power of half is actually basically just a square root of that number, which is 2. Okay, square root of 4 is 2. Okay, so what you get when you have when you calculate 3 to the power of -1. Don't forget the negative will become 1 over. So it's 1 over 3 to the power of 1, which is 3 divided by 2. Don't forget, this is very complicated. Okay, your teacher wouldn't understand whether your bracket is here or bracket is here. Your teacher wouldn't understand your bracket is 3/2 or bracket is 1 over 3. You must understand the bracket is at 1 over 3 now. Why? Why is it 1 over 3? Because you have converted this one to this one. So this one is basically 3 to the power of negative 1. Okay, so this is in a bracket. You get me? This must be in a bracket because this has successfully converted into this whole thing. So it must sit in a bracket. You must prioritize it. All right, so how do you deal with this? I don't know what to do, right? You just write it in simple terms. 1 over 3 divided by 2. Okay, 2 is actually 2 over 1. Okay, you must understand 2 is actually 2 over 1. I told you any number can be expressed as 2 over 1 or the number over 1. Okay, don't forget. So if you have 2 over 1, and I told you, what do you do when you divide a fraction? You change it to times. So you change it to 1 over 3 times 1 over 2 will give you 1 over 6. Or if you're not sure, just use your calculator. But don't forget to type the bracket in. Bracket is a very important thing if you want to calculate something in your calculator. Never ever distort the order of the brackets when you're calculating something in your calculator. It will give you a totally different answer. Right, so this ABCD discussed. I'll move on to the bottom. I'll just wait, let me see. Should I discuss everything? Wait, I got to get my charger. Oh wait, let me finish question 2 first. Okay, so I'll do very quickly. If it is similar to above, what do I do for A is that I just solve A now. Okay, A is just 3 times. I hope you can follow 1 over 4 squared. Why is it 1 over 4 squared? Because negative change to 1 over divided by 5. So what I do is that I multiply 3 top to the top. Use your calculator if you are not sure. 3 over 4 squared is 16. And this whole thing becomes this thing. So it's in a bracket divided by 5. So as usual, when you have 3 over 16 divided by 5, you can write at least 3 over 16 divided by 5 over 1, which is equals to 3 over 16 times 1 over 5, which is equals to 3 over 80. All right, this is your answer. We solve B. Okay, so you have a square root of 4 over 9 times 4 over 9 to the power of half. So if you are a person who follows my lesson closely and you really understand, you know that power of half is actually square root. So you have square root 4 over 9 times square root 4 over 9. There are so many methods to solve this question. You have square root 4 over 9 times square root 4 over 9, which will give you, what does this give you? What does square root 4 over 9 times square root 4 over 9 give you? Okay, this arises same thing. When you have same thing multiplying by the same thing, it's just because it just becomes a squared. You have a times a times a, it gives you a cubed. You understand? When you're multiplying the same thing, this is something, if you are doing it for the first time, is you might not spot it. Okay, so you're multiplying it same thing twice, so it's just square root 4 over 9, this thing square. Why square? Because I'm multiplying this thing twice. That's why I square it. I change it to like this. And then you must understand, when you have a square root and square, they are like opposite of each other. They can cancel off each other. Power, the powers, the square power and the square root can actually cancel off each other. Okay, the power and the root can actually cancel off each other if the number is same. All right, so what you get is, when you cancel these two things, what you get is 4 over 9. The actual reason of cancellation, right, is actually this. The actual reason of cancellation, I want you to understand, not just memorize cancel, cancel, cancel just for fun. Okay, what we do is we convert this square root 4 over 9 now. I'm explaining the reason to you. We convert this 4 over 9 to the power of half first. Square root 4 over 9 into this thing. All right, then we, in a bracket, to the power of 2. Okay, I'll rewrite it. It's a bit messy now. Okay, so I said square root 4 over 9 square is equals to 4 over 9 in a bracket, power of half, then you square. So I move on. Okay, so when you have power next to the power, what you do is you multiply the power. Just when you have power next to each other, you just multiply the power. All right. So when you multiply the power, right, it will disappear. You see or not? This is the cancellation that happens. To prove what I told you just now, that this actually square you can cancel with square root. Why? Why can you do it? It's actually the reason is here. The reason is because when this square root you convert it to the power of half, which you can. Okay, you know you should be able to convert this square root to power of half. Once you have converted to power of half, and you square it, what you do is that you can cancel because half times 2 will cancel the 2 and will give you 1. And 4 over 9 to the power of 1 will just give you 4 over 9. You see? So it's just simply saying that these two things are cancelling and you actually arrive to this step. All right? So that is actually this D. I want to come back to this question first. Why is square root a to the power of half? It's I did not think that you would not know just now. That's why I did not explain it. So it's actually basically based on the power on the formula whereby a to the power of m divided by n is equals to a power of m square root n. Not square root n. Take the nth root of this thing inside. Okay, basically this thing. We call it. So right, about it is that so you know that this is a square root. So the number here is 2. And when you have a by itself, you must know that a is actually a to the power of 1. Because a to the power of 1 is actually a. So it doesn't matter if I write the 1 or not. Okay, so how do I convert this into this? You just remember, always is power root. The top is power, then the root. So the power comes first, so 1 goes top. Root is the one that is next to the root, basically next to this symbol will be go bottom. That's why it's a to the power of 1 over 2. All right. So that is question B. Question C and D, I'll leave to you to do, to try by your own. All right. Okay, so we move on to question 3 now. Yeah. So question 3 is actually about, you see more unknowns. Before this, I've given you a lot of numbers to solve. Now I'm giving you unknowns to solve. So when you're solving unknowns, right, it's the same thing. You have to spot for same base and basically spot for the theory that you learned above. All right. So how do you spot for them is a minute, yeah. Oh, it's not working, my phone. All right, doesn't matter. Okay. So what you do now is we try A first. We try A. Okay. So what you have is x to the power of half times, dot basically means times x to the power of 1 over 3 divided by square root of x squared. Okay. So when I first look at this question, what will I ask myself? Okay, dot means times, okay? Okay. So I'll tell myself, where can I start this question from? Oh, I know x and x is the same base. In fact, x here is also the same base. There are a few methods to do it. I'll suggest a method that most of you will do lah. Okay, first of all, if you spot this right, as I repeat many times, when you have a square root and a square, they automatically cancel off each other. Why they cancel off each other? Because it simply means x square in a bracket, and when you have square root, it's basically power of half. So they will cancel off and they will just leave you with x. Okay, I'll just leave it here first. Later I'll rub it off. So what you do is, now you're left with x. So you have x to the power of half times x to the power of 1 over 3 divided by x only. Why? Because the square root and the square has cancelled each other off. So what do you get when you have this? You must understand this is multiplication and this is division. Multiplication, this is division. So when you have multiplication and division of the same base, I repeat, multiplication and division is the first key point I'm mentioning. Secondly is the fact that it must be the same base. what you do is that you can apply theorem, you can apply law of indices 1 and 2, law 1 and law 2, which happens to be when you multiply, you add the powers of the same base, and when you divide, you minus the power, times you plus, divide, you minus the power. All right. So what you do is, it will give you x to the power of half plus 1 over 3 y plus, because I multiply here. Okay, I multiply here. Okay, then I minus what? Okay, who can tell me minus what? Minus, as I repeat many times, I keep repeating so that you won't forget. I minus 1. Why? Why do I minus 1? Because the power of the x below here is power of 1. Anything by itself has the power of 1, has an invisible power of 1. Like, it's similar to the fact that when you have a number, it has an invisible denominator of 1. Actually, it's just 8. 8 is actually 8 over 1. Okay, it has an invisible denominator, which is the number below it. Okay, but we don't usually write it as 8 over 1. We usually write as 8 only. Similarly, 8 is actually 8 to the power of 1. So x, similarly, x is also x to the power of 1. Okay, that's why I minus 1 here. So what I'll get is x to the power of half plus 1 over 3 minus 1 will give you 5 over 6 minus 1 will give you minus 1 over 6. X to the power of minus 1 over 6. Is it? 1 over 2. Well, I'm not thinking today. A bit sleepy. Sorry. 5 over 6 minus 1. Yeah, minus 1 over 6. Okay, so what can you do with this power? You can leave it like this, or if you want to be fancy, you can change it. What does the minus power mean? Minus power means you will 1 over. Means you will, what you do is you will 1 over. This negative will change to 1 over. I repeat many times already. Then what you write below is x to the power of 1 over 6. Don't forget, this negative has disappeared. Don't ever write the negative down here. Okay, I hope you're following my lesson for you to do well. And if you all get good results, because of my help, please don't forget to come back to me. I want to congratulate you. All right, that is question A. Okay, let's move on to question B. Question B is the same thing. You have square root xy over square root x. Okay, square root xy. What? How would you solve this one? Okay. There's another tips I want to give you that you can write down in your 1/3 section here, is that when you have square root a over square root b, right, you can actually combine the square root into one big square root of a over b. Okay, this one tip that you can write down in your notes. Okay, and by writing notes, right, I hope that you're writing notes while I'm teaching. Because not while I'm teaching, after I'm teaching, you pause the video and write your own notes. I do not want you to write while I'm talking. That's the one biggest mistake you ever make. You won't realize how disastrous it is until a long term. Then you realize it. All right. In short term, you won't realize it. You will think that, oh, I understand. I'm listening. I'm understanding, but you won't realize it yourself. Similarly to something that I won't mention now. I'll mention next time when we have time. All right. So basically, square root a over square root b is equals to square root a over. Remember this thing? I might rub it off later, so don't forget to write this thing down if you do not know this thing. So I can actually combine it. The square root becomes square root of xy divided by x. So when you have these simple maths from algebra, you can solve. You can simplify it. When you have multiplication, when you have just multiplication and division only, you can actually cancel the terms. X divided by x, you can cancel them. Okay, only when there's multiplication. Multiplication only. Like this is multiplication, this is division. Then you can cancel terms. Or in other words, if you want to use the law of indices, this is x to the power of 1, this is x to the power of 1. And since they are dividing each other, it's multiplying and dividing. Okay, it's not adding. You don't see plus and minus inside here. Okay, so what can you do is you can take x when you divide, and when you're dividing same base, what do? You minus the power. Okay, so when you have x to the power of 1 minus 1, it will give you x to the power of 0, and anything to the power of 0 will give you 1. You see? So the x disappears. This x will just become 1. So you're just left with y. You understand? The x divided by x would disappear. Why? Because I've shown you here it become 1. Okay, 1, you can choose to write or you can choose not to write, because 1y is actually y. Okay, repeat, rewind the video if you don't understand, if you don't get me again. Okay, I'll try to repeat one more time. Okay, so I change it to a big square root, xy over x. So I'll get, you cancel the x. All this will be instantaneous when you're good in it, okay? Multiplication, you can divide it. Now, if you're learning new, right, the main idea is for you to make as many mistakes as possible. Why? Because you know that once you make a mistake, you will never repeat them. That is the condition that lies underneath. If you're not promising yourself this must of not repeating the mistake, then making a mistake. You get what I mean? To make a mistake, making a mistake to not be a mistake. You get what I mean? To making a mistake to not be a mistake, you got to not repeat the mistake. Oh, it's very confusing, but never mind. Basically, in simple words, do not repeat mistakes. I keep emphasizing, even though it's a simple thing that everyone tells you since young, but until you really know how to actually apply them, you realize how beneficial it is to you. It's like a compounding. It has a compounding effect in your knowledge. You get what I mean? The mistakes that you learn from, right, will prove to you greater results in the future. Slowly, when you compound more and more of the mistakes that you learn. All right, so it will give you square root of y. Y, or I can write it square root of 1y. Why 1? Because x divided by x gives you 1. Okay? Or I can ignore the y, I can ignore the 1. I just write square root of y. Okay, we move on to C. I won't discuss C and D, okay? I won't discuss C and D. I'll leave it for you to try by yourself. All right, because I want to move on to the harder questions. Okay, question 4. Question 4, solve the following. Okay, so they want you to solve. Solve basically means, did they ask you to solve? They are not supposed to ask you to solve this question. Maybe they meant to say simplify, okay? Okay, but never mind. Basically, when you look at this question, what you do is that you want to, this is very complex. You want to complete it to make it to be something simpler. That's why you simplify it, okay? So when you look at this type of questions, right, normally when I spot this kind of question, right, I immediately know what type of question it is. Why do I know what type of question it is so quickly? Because experience tells me. How does my experience tell me? How do my experiences tell me that I actually spot this question so quickly? That allows me to spot this question so quickly is that I've made enough mistakes to learn that experience. Okay, so the first step is to make mistakes. It doesn't matter if you make mistakes, okay? Once you make the mistakes, learn from it, and that becomes your experience. And that experience is going to pave a road for you to spot things quickly. So I know I straight away spot when you see questions like this, right? You know 3, 9, 27 are of the same base. What do I mean are of the same base? It means that 9, 27 can be expressed in terms of 3 to the power of something. Can be expressed in base 3 means can be expressed as 3 to the power of n. For example, 27 is actually 3 times 3 times 3, or you can call it 3 to the power of 3 because you times it 3 times. Okay, 9 is actually 3 times, or actually 3 squared. So as long as you can express it as a base of 3 to the power of something, you know that this question you have to use this method. And what is the method? Just follow my steps, then you will get it. All right. So what do you do is that all right. So you know that this is already 3, base 3. What is the idea of behind this kind of questions, right? In fact, in most of this type of question is to change everything to the same base if possible. In this chapter, right, whatever you're facing with, almost all the questions that you're facing with, if you can change them into the same base, change them into the same base. Okay, why we want to change them to the same base? Because when we change them into the same base, we can apply these two, oh my lord, we can apply these two laws of indices, because they must be the same base, only can do it. You understand? So what we do is that we first change them to the same base. So how can I change it? So we are going to change this to base 3, okay? We change it to the smallest base possible. So 3p plus 1, I don't have to change because it's in the base 3 already. Base 3 means the base is 3 lah. As I told you, okay, this is the base, this is the index. Earlier I told you already, I think. Okay, so you have base and index. I change the base 3. Basically, I want the number to be 3. So times 9 is actually 3 to the power of 2, power of p, divided by 27 is actually 3 to the power of 3 times 2 over to the power of 2 over 3p. Okay, so this one I rewrite times power side by side, multiply them, 3 to the power of 2p, divided by power side by side, multiply them, 3 to the power of 2 over 3 times 3, cancel the 3 and 3, you get 2p. And questions like why can you cancel and why sometimes I cancel wrongly, you can ask me if you want to. You can ask me in the comments and I'll actually make a video. This might sound simple, okay, but if it is helpful for you, I will just do a video for you. Because many people are ashamed to ask this kind of question because they think it's too simple. And these are actually the detrimental factors that actually cause someone to not do well. Because your foundation is not even there. What's the point of building such a big building if you don't even know what to build the building with? What are you building the building with? You get what I mean? So get your foundation right lah. That's what I'm trying to say. All right. So what you do is you have multiply, divide, first condition, second condition, same base. So I straight away know when it's multiplication or division and it's the same base, I can apply the law of law of indices. When you times, you add the power. These two powers you add, p plus 1 plus 2p. Then I minus 2p. Why I minus 2p? Because divide. When I'm dividing same base, I will minus the powers. So I'll get 3 to the power of, you see this is 2p and 2p. Exactly same thing, minus each other off, you get 0. Okay, my mom gave me an apple and she took the same apple back. I'm left with nothing. All right, so you're left with nothing, so it's just left with p plus 1. Okay, this is the final answer. That is A, okay? This kind of question, you just try to solve, convert them into the same base lah. That's the idea. All right, I hope you have written down. Sorry for not informing you earlier that you should write first before I wrap it off. Okay, question B is a bit different now. If you realize, right, question B is another type of question. You see now, if I were you, I would straight tell myself, question B is like another type of question compared to question A. Question A, right, you can all change to the same base. But question B, you cannot. Why cannot? You might be asking, why do you know so fast that you cannot do it? It's because my experience tells me. Why my experience tells me? Because I made enough mistakes. I keep repeating the same thing. Because I want you to wire in your brain that this is so important. Okay, so if you cannot change to the same base, right? What can you do is you break it down. You break everything down. Then you see. You realize that 6 is actually a multiplication of 2 times 3. Okay, 27 is actually 3 to the power of 3. Okay, don't forget this one. I try to break things down first. Okay, you try to break everything down. 12 is actually 3 times 4, which is actually 3 times 2 times 2. Try to find the prime factors. Or in other words, try to find what times what gives you 12. The simplest numbers that multiply each other to get 12. Try to do that. 32 is equals to what? 16 times 2, which is equals to what? 8 times 2 times 2, because 8 times 2 gives you 16. Which is equals to what? 8 is equals to 4 times 2. Then at the back, times 2 times 2, which is equals to what? 2 times 2 will give you 4 times 2 times 2 times 2. So it's actually 2 to the power of 5. Okay? If I've enough experience to tell myself that 62 is actually 2 to the power of 5, 64 is 2 to the power of 6. But if you do not know, you try to break it down. Okay? If you have done enough questions, then you will automatically know these things quite well. Okay, so you realize, right? Look at these numbers. 2 to the power of 5, I've broken it down, 2 to the power of 5, 3 times 2 times 2, and 3 to the power of 3 and 2 times 3. You realize that even though they are not the same base, but they are actually two bases only, base 3 and base 2. Okay, the power is not included because I'm carrying for the base only, okay? You see, this is 2 and 3, the base is 2 and 3, 2 to the power of 1 and 3 to the power of 1. So the base is 2 and 3. So the base is 3, the base is 3, 2, 2. The base is 2. Okay, so everything is in the base of 3 and 2. So I can classify in a family of 3 and classify in a family of 2. So what I do is, I rewrite them first. I don't have enough space, I think. I got to move to somewhere to write this answer. You know what? I'll just rub this 1/3 section off, but please do not rub for your case, okay? Okay, so what I'll do now is that, watch out here. I'll break it down first. I'll try to break everything down. This is the type of question of breaking it down. 2 times 3 to the power of n over 2 times 27 is 3 to the power of 3, as I told you just now, to the power of negative half n times 12 is 3 times 2 times 2. 12 is 3 times 2 times 2, which is 2 squared. 2 times 2 is 2 squared. Power of n plus 1. Then I divide. Okay, I realize I'm running short of space. You know what? What I'll do is I'll add 1 page first. I'll add 1 page. Then I will do the question down here. Okay, so the question is 6 to the power of n over 2 times 27 to the power of negative n times, don't feel it's tougher, it's your mindset that's tricking you, because it's just that you've got to learn from your mistakes. So as I said, you break it down, this is 2 times 3 to the power of n over 2 times 27 is 3 cubed to the power of negative half n times 12 is basically 3 times 4, which is 3 times 2 squared, because 4 is 2 squared. I'm trying to break everything down. 4 can be broken down into 2, I'll break it down until I cannot break it down, until it's a prime number, to be exactly correct. But if you're not sure what I'm trying to say, is to try to break down everything to simplest ever break possible. Okay, like 3 cannot be broken down into something times something anymore. It cannot be broken down into multiplication of 2 numbers. We are not counting decimals, okay? So 3 times 2 squared to the power of n plus 1. Then you divide by 32 is 2 to the power of 5, as I explained just now, to the power of half n. All right. So what you do now is that you try to group the okay, you must know that whenever it's multiplication inside and you have a power outside, you know what rule you can use is that the rule of a b power of n is equals to a power n b power n. All right, you can multiply the power inside. Why can you multiply the power inside? Because it's multiplication inside. So it's multiplication inside, you can multiply the power individually. So I'll break it out everything first for you to see clearly. It's 2 to the power of n over 2 times 3 to the power of n over 2 times. Okay, so I times, because, okay, these two, what theory am I going to use? What law I'm going to use? I'm going to use the law, the third law, whereby I multiply the powers together, which is 3 to the power of negative 3 over 2n. Refer back to the law, as I said, times. Okay, this one is the same thing. You don't be scared of n plus 1. Don't be scared. Even they give you n squared plus 2n plus 1. Don't be scared. As long it's a power, just think of it as a power. This whole thing as a power. If there's a bracket, right, you can think of it as like an n only. You get what I mean? Think of it as a single item. So this thing, when you have multiplication and then you have power, what you do is you times the power inside. Okay, so 3, when you bring the power here, it will give you 3 to the power of n plus 1 times 2 squared. This is 2 squared to the power of n plus 1. Okay, which later will combine together when you times them together. And then divided by 2 to the power of 5 over 2n. I hope you know why is it 5 over 2n now, because power side by side, multiply them. Okay, so this one, right, I don't want to write one extra long step to just for this one, so I'll write this one here, okay? So 2 to the power of 2, when you have 2 powers next to each other, what do? You just multiply them together. So 2 to the power of 2 times in the bracket n plus 1, what will it give you? This is another one thing I want you to write in your one-third section. When you have 2 to the power of 2 times n plus 1, right, what you get plus 2, not 2n plus 1. Many people just take the 2 times n. Okay, you must multiply every single term. This is something that you must remember also. Okay, you might sound confusing because you might sound confused because a lot of things I'm actually throwing to you, but slowly take your time. Okay, spot the difference. Oh, now I'm dealing with addition and subtraction, and now I'm dealing with multiplication of a number and an addition in a bracket. So you must be clear. As I said, it comes back to the principle. You must be clear of what you are doing. You must be organized. All right. So once I'm done with this, what I can do now is I can, so this power I can actually erase it to change it to 2n plus 2 straight away. All right. So what I do now is that I group the powers together. Okay. The power of 2 I group together. So when I group the power of 2 together, is it multiplication or division? It's multiplication, right? When you want to look whether it's multiplication or division, look at the sign in front of the term, not behind, okay? Like for this term, it's multiplication. For this term, it's division, all right? For example, 2 plus 3, the plus belongs to this 3, and there's actually a hidden plus in front of this 2, okay? Always look at the sign in front of the term. So that's another wanted section thing you can write it down if you want to, all right? If I were you, I would write it down if I do not know it. Okay, so 2 to the power of, when multiply, you plus the power n over 2 plus 2n plus 2, then you minus. Why minus? Because this is divide. When you divide, and what law am I applying? I'm applying the first law, okay, first and second law, where you times the same base. Same base is 2. Or divide the same base, you just can play with the powers. You can just plus the powers and minus the powers. All right, when it's divide, I minus 5 over 2 n. All right, so what I'll get here is, I will calculate later in the next step. Now I'm done with family of 2. Now I deal with the family of 3. I times with, because everything is times, so I times 3, group of 3 now. Starts with n over 2. Then you times, right? So you plus the power of this power, plus negative 3 over 2n. Don't be scared of this negative. Just treat it as one power, as I said. Don't care about whatever is given to you. Just treat this as one thing, okay? If you don't like it, just put a bracket so that you remind yourself it's just something that you don't have to care. Just copy whatever they give you, plus negative 3 over 2. Then you deal with this later. All right. Then since it's a times in front of this 3, so I plus this power, n plus 1. Okay, so I simplify them. Don't forget to put the equals. When I simplify them, what do I get? N plus 2. Since it's plus, I can open up the bracket straight away. Type in your calculator, n plus 2 plus 2. N over 2. Group the like terms together, okay? These are like terms. The one with n is the like terms. I won't explain so much on this type of basic operation. If not, it will be very, very wasteful of time. So what you do is you add, when they have the like terms, basically, and when everything has n, you can operate them. You can plus, minus, times, divide. You can plus or minus them. All right. So n over 2 plus 2n minus 5 over 2n will give you 5 over 2n minus 5 over 10. Won't give you anything, okay? Will give you 0n. 0n is 0 lah, basically 0 plus 2. This 2 is from here. This is from n. This is from the n. N over 2 plus 2n minus 5 over 2n. Okay? So the n disappears, which is very nice. Okay? Then you times 3. Okay, this one, okay, as I said, n over 2 plus minus, open the bracket, gives you minus 3 over 2 plus n plus 1. Okay? So it's equals to 2 to the power of 3 to the power of, as I said, the one with n, you can calculate them together. You can only add or minus things that are in the same family. So how do you know if they're in the same family? They must be like terms. How do you know they are like terms? They must have the same unknown. Okay, they have the same unknown for these two, which is n and n. So what you do is n over 2 plus n will give you 3 over 2n. Then minus 3 over 2, number and number falls in the same family or in the same, like they are like terms. You call it in mathematics, they are like terms. Or I call them in the same family. N and n is in the same family. Negative 3 over 2 plus 1 is in the same family. So negative 3 over 2, this is n. Negative 3 over 2 plus 1 gives you negative half. Okay, so you get this answer 4 times 3 over 2 n minus half. I'm not sure whether I made any calculation mistake or not. So anything you want to write, you can just write, pause the video and write before I rub everything off. Okay, you just pause the video, okay? Because I'll rub it off now. So this is actually question 4b. Okay, This is question 4b. All right. So now we move on to question 5. Question 5, I will only do one question, okay? And the rest, I'll do 1 or 2 questions, then the rest you should try yourself. Where's question 6? Oh, it's here. Okay, for question 5, it's a question of divisibility. Divisibility. What is divisibility? Is able to divide or not? Able to divide without giving remainder or not? Without remainder. For example, if I take 4 divided by 2, I'll get 2. But if I get 3 divided by 2, I'll get 1 and 1 over 2, which is not an integer. All right, it's not nice. This number is not nice. It has a remainder. If you use primary method, you take 3 divided by 2, you get 1, then you have a 2 here, then you're left with 1. That's a here, which is no good. Okay, for this case, no good. So it's not divisible. 3 is not divisible by 2. Okay, if you can divide by 2 and give you a perfect number integer, you call it divisible. 4 is divisible by 2, or 4 can be divided by 2. Okay, so that's about divisibility. Divisibility is the able to divide without giving you remainder. So that show that this is another type of question. You see, I keep repeating the type of question. If you realize my lessons, I organize it in a special way, other than me trying to nag about the same thing, repeat over and over again for your benefits. After all, I actually tend to repeat certain things, like the type of question. You see, question 5 is a type of question that it's a special type. It's about divisibility. So show that 3n, 3 to the power of n, this is question 5a. 3n minus 3 power of n plus 1 plus 3 to the power of n plus is divisible by 7. For all positive integers. Integers are basically numbers which are not fraction or not decimals. Okay, can be positive, it can be negative. Of n. Oh my gosh, my writing, I'm so sorry. All right. So what you do is divisible by 7 means something you divide by 7, you won't give you a remainder. For example, 49. 49 you divide by 7, you get 7, and then you get exactly 49 with no remainder. Perfect. Okay. So this is something you want to find. This thing is something that can be divided by 7. All right. So this thing, you can think of it as this thing is something like 49. Once you divide by 7, it will give you no remainder. Okay, how to prove it? It's about how do you prove it? The idea is to bring out a 7. You see, the idea is to make this thing in terms of a 7 times something, blah, blah, blah. Okay, why to get this? Why do I want to get this? Good question if you're asking that. If you're not, never mind. Train yourself to ask questions like this next time. Why? Keep asking why. All right, why am I doing this? Because once I have the answer in this form, I know that this answer is always divisible by 7. Why? Because when I take this answer, whatever is, I don't care whatever is here, I divide it by 7, I can always divide by 7. Can you see? I can cancel the 7. Why? Okay, now why I can cancel the 7? Because it's a multiplication. I repeat again, now when it's multiplication and division only, you can cancel. Okay, you can cancel. So I can cancel. This is something you want to write it down if you want to as well. So I can cancel. So in every case, so if I can write this thing in the form of this, I know that this thing is always divisible by 7. It can be divided by 7. Once I divide a 7, it can cancel on the top. That shows that it can be divided by 7. This thing, which is the question, can be divided by 7. Okay, I just express this thing in terms of 7 times something. And then why am I dividing by 7? Because I'm trying to check whether it can be divided by 7 or not. Right? So this is the idea. So the working for this question is I'm trying to pull a 7 out. So how do I pull the 7 out? Is a method called factorization. Okay, factorization. There are so many things I want to explain, but I cannot explain in just one video. If you all want me to explain, I can try to explain it. Okay. All right. So what I'm going to do with you is I'll try to break it up. I'll give you two methods. I'll give you two methods. I see which is simple for you. Method one is what most teachers would teach. Method one is basically you break it up. You see the powers here, right? You break it up. We have 3 to the power minus. How do you break this up? Okay, remember the theorem. Remember the theorem. I remind you again. A to the power of n times a to the power of m is equals to a to the power of n plus m. Similarly, if you want to break this up, you can break it up in the opposite direction. A to the power of n plus m, you can actually break it up to a to the power of n times a to the power of m. Okay, basically they must be the same base. So actually I can break this 3 to the power of n plus 1 into 3 to the power of n times 3 to the power of 1. Okay, then I plus. Similarly, this is n plus 2, so I can break it up into 3 to the power of n times 3 to the power of 2. Check back. Once I times this one, do I get back the same thing or not? Do I get back this thing? You will. Why? Because same base, different powers. Same base, what I do is I combine by adding the power n plus 2, which is similar to this. Correct. I'm just working the opposite direction. So you must be familiar with opposite direction also, okay? As you move on with your work. So what I do is, what's the point of doing this? You see, if you are following my lesson, you ask why. Why I want to do this? I hope you're asking why in every step. Why am I doing this? What is this step for? This step is for you to pull out this exactly identical 3 to the power of n. I give you one example now. If I have a minus a plus a times 3 plus a times 9, what can I do about this? What can I do about this? Do you know what I can do about this? If every single term separated by a plus or minus is called factorization. If every single term separated by plus or minus, okay, separated by plus or minus, for example, every term here can be divided by a. You see, now this one can be divided by a. This term also can be divided by a. Why? Because if I divide by a, I can just cancel this a. This term can be divided by a. This term also can be divided by a. It has a. So what you can do is you can pull out the a. Okay? When you want to pull out the a, you must pull out from 3 of this term, okay? Separated by plus or minus. So when you pull it out, right, what is left for this family, first family, is that you're left with 1. Why 1? Because you take a divided by a. A divided by a. What is the idea is basically, right, you just divide every term here with a. Divide by a, divide by a, divide by a. Okay, then once you have done that, you can pull out the a. That's the idea, okay? So when the first time you divide a with a, you get 1. Because anything divided by itself, you get 1. Minus, okay, a, okay, I told you multiplication. When there's multiplication and division only, you can cancel. So you're left with 3. And then plus, when it's multiplication and division inside here, you can cancel. A and a can cancel, which is plus 9. This plus is this plus, this minus is this minus. Okay, it might sound complicated if you're not good in maths, but if you are that person, please let me know if I need to make another video, especially for all this kind of basic operation. I assume that you have basic operations in your mind already. Okay, so I'm not going to go so far about this. So what you get is a minus 2 plus 7, minus 2 plus 9 gives you 7. So it's 7a. You get what I mean? It's about factorizing, factorizing the terms out. This is called factorizing. Factorizing is basically opposite of expanding. Okay, I explain that in another video if you want to. If not, this video is going to get so long. This by explaining just the first principle. Okay, so for this example, right, each of the term has 3 to the power of n. So I can pull 3 to the power of n out, and then what is left? 3 to the power of n divide by this, because I'm pulling one 3 to the power of n out. So I divide by 3 power n. So I take this one divided by itself. Same thing divided by same thing gives you 1. Minus is because of this minus. This thing, I'm pulling 3 to the power of n from this family now. Okay, so when I pull 3 to the power of n from this family, I just divide by 3 to the power of n. I can just cancel with this 3 to the power of n. What I'm left with is 3. Okay. Okay, then I plus. Why plus? Because of this plus. Now it's the third family's time. What I will do is I will divide this thing with 3 to the power of n. Okay. Okay, why do I divide by 3 power n? You might ask, you might get lost again. Why do I divide by 3 power n? Because now I want to factorize 3 to the power of n out. Do you get me? I want to factorize 3 power n out, as simple as that. So the method Brian told me is that if I want to factorize 3 to the power of n out, I must divide each term with 3 to the power of n. If I want to factorize a out, I must divide each term with a. If I want to factorize 2 out, I must divide each term with 2. I want to factorize 6 out, I must divide every term with 6. And each of the terms are separated by plus or minus. Don't ever forget that, plus or minus. Okay, so don't forget, if I were you, I'll write down the notes are separated by plus or minus. And then if I want to factorize, the word is factorize. Factorize means you pull out. If I want to factorize n, for example, I need to divide each of the term by n. For example, how many terms are there here? 3 terms. 1, 2, 3. How do you know how many terms are there? You count how many of them that are separated by plus or minus only. You don't count this as 1 term, 2 term, okay? This is 1 term by itself because it's multiplying. Term are only separated by plus or minus. So plus and minus is here. So there are 1 term, 2 term, 3 terms. Briefly explain to you, okay? So I have to take out the power from each of the term. I'll take out whatever you want to factorize from each of them. I take out 3 to the power of n. So I divide by 3 to the power of n. First term will give you 1. Second term will give you 3y because this one will disappear after I divide by 3 power n. And the third one, I divide, it will give you minus 9. All right. So what I'll get is 3 to the power of, oh my gosh, the colors combination. I'll get 3 to the power of n. 1 minus 3 minus 9 is minus 12. 1 minus 12 is minus 11. Right? Did I copy the wrong question somehow? I think I copied the wrong question. Did I do something wrongly? I might have done something wrongly, or I might have. I'm going to rub everything off and retry by myself because it's very messy. Because when I explain, it tends to get messy. The important thing is not to get the right answer. I want to explain how I get it. You understand? So, wait. 3 power n. 3 power of. I try myself first here. 3 power of n minus 3 power n plus 1. Let me copy back the same question. Plus 3 to the power of n plus 2. Okay, so I have 3 to the power of n minus 3 power of n times 3 plus 3 to the power of n times 3 power of 2. So what I do is I factorize the 3 to the power of n. So when I factorize it, I divide each term with the thing. So I divide this one with 3 power n. 3 power n divided by 3 power n will give you 1. Minus this thing divided by 3 power n will give you 3. This thing, oh, I think I made a mistake. I think I made a mistake somewhere around here. I don't remember where I made a mistake, but it's all right. Y'all can spot my mistake and let me know in the comment. This is like a homework where you can see it shows whether you're focusing or not. So I'll just leave it uncut, okay? I won't cut this part off. See whether you spot the mistake or not, to see whether you're focusing or not. Let me know if you spot it and let me know in the comments, all right? Okay, so coming back to the question, right? I try to redo the question, okay? You have 3 to the power of n minus 3 to the power of n plus 1 plus 3 to the power of n plus 2. So what you'll get is basically 3 to the power of n. I'll briefly run it through very fast because I've taught you just now. 3 to the power of n times 3. Then this is 3 to the power of n times 3 to the power of 2. Okay, so it's equals to, I want to divide each term. I want to factorize. Okay, now the step I want to do is I want to factorize 3 to the power of n. What do you mean by factorize? What do you mean by factorizing 3 to the power of n? I'm pulling out 3 to the power of n from each of the terms separated by plus or minus. I repeat my sentence. If I want to factorize 3 to the power of n, what do? I write down if you need to, okay? I am pulling out by what I mean pulling out is you divide each of the term separated by plus or minus. Each of the term, right? There are 3 terms here, 1 term, 2 term, 3 terms. Okay, you divide them by the thing that you're factorizing out. which is 3 to the power of n. So this term divided by 3 power of n will give you 1, because 3 to the power of n divided by 3 power of n will give you 1, minus this thing divided by 3 to the power of n will cut the 3 to the power of n and leave you with this 3, minus 3, plus similarly this one you divide by 3 power of n will give you 3 squared. So this will give you 7. Oh, I'm so sorry, my working is so terrible. Sorry, I'm a bit sleepy today. Hope you don't mind. 3 to the power of n, you must write the 3 power of n. Okay, that's the purpose of factorizing. When you're factorizing, you're actually pulling it out. That's why you're writing the 3 to the power of n outside. Okay, 1 minus 3 plus 3 squared, which is 9. So this is 3 to the power of n times 7. Oh, you see, this is what I want to see. Correct? No? I told you just now. You want to get something, multiply with 7. So when you have something multiplied with 7, you know that this is always divisible by 7, because it already has a 7 inside. You get what I mean? Or not? The logic is that you already have a 7 inside. So when you, whatever n is, right, I prove to you, if you do not understand something, try to make it as simple as it is for yourself to understand it. Okay, so if you want to make it simple, right, when you choose n equals to 1, what happens when n equals to 1? You have 3 times 7, 3 power of 1 times 7, which is 21. Can 21 be divided by 7? Can. It will give you 3. You get what I mean? It will give you 3. 21 divided by 7 gives you 3. Okay, when n equals to 2, it gives you 3 squared, which is 9 times 7. 9 times 7 is 63. Can I divide it by 7? You want to check whether it's divisible by 7 or not? Yes, because it gives you 9. So where did this 9 come from? It actually came from this thing. Where did this 3 come from? It actually came from this thing. In other words, what I'm trying to deliver to you is that since you can express this thing as 7 multiplying with something, when you divide it with 7, right, you can cancel it every single time. So in other words, this thing is always divisible by 7, because you can cancel with 7 every time. Why you can cancel with 7 every time? Because you have a 7 here. Logical. Since you have a 7 here, okay, I'll use back the general example here in the question. Since you have a 7 here, it means that you can actually divide with 7 every single time. Okay, so you have a statement. Okay, this kind of question, divisibility, you must have a statement. Since or you can say, since this thing, 3 to the power of n minus 3 to the power of n minus 1, n plus 1 plus 3 to the power of n plus 2 can be expressed. Okay, understand the sentence. It can be expressed in this because I derived this thing from this by factorizing 3 to the power of n out. Can be expressed as 3 to the power of n times 7. Okay, therefore, okay, we don't write this. We don't write a therefore here. Since this one, therefore, it is divisible. You can just say it is divisible. It's understood when you have the 7 here that it is divisible, is always divisible by 7, and always follow the sentence. If the sentence for positive integer of n, follow positive integer of n for all positive integer of n. Okay, I teach you one symbol you can use to be fancy a bit of n. Okay, positive integer, you can write it as a z with another line with a plus. Z means integer, plus means positive integer. And what is integer? As I repeat many times, integer is a number that is not a fraction and not a decimal. All right, and integer can be plus or minus. Okay, so -2 is an integer, 0 is an integer, 4 is an integer, 4.1 is not an integer, 2/3 is not an integer. Okay, so I want you to take note of that. You can write it as this symbol if you want to. All right, so if you want to take notes, you can take notes first. This is the first method that I'm going through. The second method, I won't recommend the second method even though I personally use the second method actually myself. But I won't show you now. I won't show you here. Okay, what I'll show you is just this. Okay, the rest of the questions, right? As for why, you might be asking me, why is it positive integer? I leave for you to think of it, and if you want, you can tell me in the comment section below why it must be positive integers of n. So in order to know why it is positive integers of n, right, you do not know where to start, right? Try with simple numbers. You try, if it is negative integer of n, you substitute n with a negative number. What will happen? And you see, and that's the homework that I'm giving to you, okay? So I've done A, right? B and C is exactly same, okay? Exactly same. You just have got to express it, all right? Yep, you just got to express it. Let me see, anything or not. This, a hint for you, this one, you just break it up to 3 times 7, okay? And then this 7, you're going to multiply with this because it's in the same base. So this power of 1 can plus this power of n minus 1. Okay, this is a hint for you. I'm not going to go through these 2 questions. All right, this is a question of divisibility. All right, okay, so we are left with question 6 now. Question 6 and question 7. Question 6 is about solving equation. Okay, solving equation, right, means you want to find x. You want to find what's the value of x. Okay, when you see equal sign and you have x, right, normally they ask you to solve for x. All right, so I will solve question 6 above this page lah. So I will solve 2 questions lah. The rest you will try to do it yourself. I'll solve question A and B. Okay, question A and B. So question A. Question A is 27 to the power of 2x minus 1 equals to 9 to the power of 5x. Okay, so when you have this, right, immediately I told you this is something like the type 1 question. Remember, I told you when you think of it, right, straight away I know that 27 and 9, I straight away know that when you're solving anything, remember I told you, always try to make them into the same base if possible. If not possible, only think of alternatives. If possible, change them to the same base. Ask yourself, are they changeable to be the same base? And the answer is yes. Because if you have done enough questions, you will notice that, oh my gosh, my iPad is not working now. For some reason. A minute. What's my iPad not working? Wait, yeah. I try to open up my log. Wait a minute. My pen is not working right now. Oh, it's back finally. Okay, so what I want you to do, okay, I'm going to go through question 6 again. There are some hiccups just now, some problems. Doesn't matter. Okay, question 6 is about this. So you can change them into the same base. So what I want you to do is that you change them to the same base. Okay, so how do you change them to the same base is you change them to the same base lah. You know that 27 is 3 to the power of 3. And then you have a power outside, don't forget to write it. Equals to 3 to the power of 2. Power outside is 5x. So power next to power, multiply the powers. And when you multiply them, I explained earlier already, when you multiply a number with a fraction, don't forget to times inside and inside. Okay, you times inside and inside, you get 6x minus 3. Don't just times the first one only and not times the second one, okay? Get used to the pattern. When you have plus and minus times the number, you must times every single term inside. Okay, is equals to this one, you times, you get 3 to the power of 10x. 2 times 5x is 10x. All right, so if any of you have any problems with basic operations that you want me to go through right in detail, like somehow like this, I can go through. You just leave a comment in the comment section below. All right, and what you'll get is okay. The purpose of many of the questions in this topic, right, in this basically this whole chapter, right, is about making things to be similar. To be 3 to the power of something is equals to 3 to the power of something. When you have this, you can compare. Since this thing, right, and they are equal to each other, you can therefore say that this thing is actually same as this thing by comparing. Or you can say, hence, 6x minus 3 is equals to 10x. Okay, because they're equal to each other and they are both power of 3. You get what I mean? If I have 2 is equals to 2, right? 2 is equals to 2. 2 cannot be equals to 3. So if 2 power here is 1, here must also be 1. You get what I mean? Because they're equal to each other. This is the idea, you know. You see or not? Whenever you tend to not understand something, right? Try to look at the simple version of it and try to input to yourself. Tell yourself, oh, the simple version of it is like this. So I know that, therefore, it is applicable here. So you can just compare the powers up there because they must be equal to each other. For example, 2 power 1 equals 2 power 1. 1 is equals to 1. But for example, for this case, you're solving for x. So you make them equal to each other. 6x minus 3 is equals to 10. You get 4x equals to minus 3. X equals to minus 3 over 4. This is question 6. All right, so you have solved for x. That's question 6. Question 7. No. I mean question 6b. 6b is 4 to the power of 4x minus 2 is equals to square root of 64x minus 10. Okay, so when I see 4 and 64, I can immediately think that they are originated from the same base, which is base 2. Actually, for this question, you can actually change it to base 2 or you can change it to base 4. But since I've taught you that you change it to the simplest one, I will do base 2 first. All right, I'll do base 2. Change everything to base 2. Okay, so this is 2 to the power of 2, and you have 4x minus 2 is equals to 2 to the power of 6. 64 is 2 to the power of 6. You can check with calculator. Every time when you see this type of question, check whether they can be converted into the same base or not. Just okay, you know that 2 times 2, that for sure you know. You can change to base 2. For sure you know you can change 4 to base 2. So you want to know whether you can change 64 to base 2 or not, you just use your calculator, keep timesing. 2 times 2 times 2, what do you get? Or you don't get 64, times 2 again, what do you get? Or you don't get 64, times 2 again, do you get 64? Or you don't get, times 2 again, do you get 64? Or you get 64. So you can express 64 as a base 2 of how many 2's? 6 power of 6, because there are 6 2's here. So you take 2 to the power of 6 times x minus 10, because this is a power outside, don't forget, and then you have a square root outside. Okay, and I want to do it simple. I want to do it in one step. This square root outside, I want to convert it into a big bracket with a power of half. Remember, I told you square root can be converted into the power of half. So you can do this. So what you do is 2 to the power of 8x minus 4 is equals to, why I can get 8x minus 4? Because I can multiply this one inside. And why can I multiply them inside? Because of the law of indices number 3. This one similarly, even though it's 3 powers, it doesn't matter. As long as they're side by side, you can multiply them. So when you multiply them, what do you get is, first of all, I multiply half with 6. Half of 6 is 3. So when you multiply 3, this one is gone. When you multiply 3 inside, you get 3x minus 30. Okay, so now you have reached a stage where you have the same base and you have this thing. So if they are equal, by math logic, you would know that the top must be also equal because they are equal in nature. So they must be equal up there also, correct or not? So you have 8x minus 4 is equals to 3x minus 30. Hence, what you'll get, 5x is equals to minus 26, x equals to minus 26 over 5. You see, in this teaching session, right, I might make mistakes from here, from time. The important thing is not about the mistake, okay? The important thing is about you learn the process, the steps, the technique, the lessons, the importance of not repeating the mistakes. These are the very important stuff that I want you to notice, okay? Question 7. Question 7 I'll do down here. Okay, question 7 is a funny question. It's another type of question you see. I highlight it because it's quite a tough question to many of the students. You might ask me, why got simultaneous question in this one? Okay, there might be, okay? You can have all kinds of questions, okay? What you have got to do is not be scared and improve your reservoir of type of question. So, okay, now, once I've gone through this question, you have another extra question in your mind already. All right? So what you do is, do what you can do, okay? So you realize that these 3 numbers are actually in bases of 5. How do I know? It's experience, okay? So if you do not know, means you do not have experience. So how can you improve your experience? Is by learning. Is by not making mistakes. Okay, when you see numbers like this, is by remembering that I told you. Whenever you solve question of numbers, when you see different numbers, try to make them into the same base. If you can, try. If you cannot, then forget about it. Then try other methods, which I'll teach you in further lessons. All right. So try to bring them into similar bases. 125 is actually 5 to the power of 3 if you calculate in your calculator. So I will convert this to 5 to the power of 3 and then to the power of x divided by 5 to the power of 2. 25 is 5 to the power of 2. Power of y is equals to 5 to the power of 4. So what can I do? Okay, so this is 5 to the power of 3x and this is 5 to the power of 2y. Okay, I can multiply them together. So what I'll get? Okay, so I'll get 5 to the power of 3x divided by 5 to the power of 2y is equals to 5 to the power of 4. And I have division. When I have division, when I look at the left-hand side only, okay, I look at this thing, okay. When I have division of the same base, I can just minus the power. So I'll get 5 to the power of 3x minus 2y. Why can I do this? Because they are the same base, base of 5. Okay, so it's equals to 5 to the power of 4. And we have reached a stage where base. So by logic, you know that when these two things, whole thing are equal and their bases are equal, the power must also be equal. Okay, so you have 3x minus 2y is equals to 4. This is your first equation. All right, this is your first equation. Why they call it simultaneous equation? It's because you need more than one equation to solve more than one unknowns. How many unknowns do you spot here? 2 unknowns. So mathematically, you need 2 equations to solve for this equation, to solve for x and y. Okay, because there are possible and ranges of answer if you just have one equation. So the idea of simultaneous equation is to solve an equation of more than one unknown. For example, there are 2 unknowns here, so you need another equation. Where is the second equation going to come from? From this thing. That is why they provide you with two stuff for you to get 2 equations to solve for 2 unknowns. All right. So this is for first part. The second part I want you to. So when I spot right, I straight away know 81, 3, and 9 are in the same family. They are in the same family of base 3. So what I'll do, 9 is actually 3 to the power of 2 or 3 squared. And then power of x is equals to 81 is actually 3 to the power of 4. Type in your calculator, as I said, always check for the same base. Power of y divided by 3 to the power of 1. Okay, so what I want you to do is when they are side by side, you can multiply the power is equals to 3 to the power of 4y divided by 3 to the power of 1. All right, so look at the right hand side. Look at the right hand side, okay? You have 3 to the power of 2x is equals to, can I divide these two things? Can I combine them? Yes. Why can you? Because they are in the same base. Okay, so when they're in the same base, you just minus the power. Since it's a division, so you just minus the power. Power of 4y minus power of 1. So you get this. So I repeat again, since they're equal, the whole thing, and same base, they should have the same power or index as well. So hence you know that 2x is equals to 4y minus 1. I'm equating these two things together, okay? Because they're equal. Since we know that they have the same base and they're actually equal to each other. So I can equal them. So I have another equation here. I'll try to rearrange them, okay? I'll try to rearrange them depending on, in following this one. I'll write in terms of x, plus or minus, I don't care, y, then equals to number. I'll arrange it in this form because I'm going to use the elimination method of simultaneous equation. Okay, so I arrange it into x, 2x, minus 4y equals to -1. Why I arrange it this form? Because I want to perform a method that requires me to arrange it in this form. Okay, so I have equation 2. So I put it down here, okay, so it's easily -1, this is equation 2. So what I do, right, elimination method is I will just do it, I won't explain it too much. I will try to explain more in the chapter of simultaneous equation. So what I do is I take 1 times 2. The purpose of doing 1 times 2 is that I want to make this number to be same as this number. Okay, the 2 to be 4. So I times 2. So when I times 2, what I get? The whole equation I times 2. Because this 1 in the circle, right, it means the equation. That's why I label this equation 1. I label this equation 2. Okay, I label this. So equation times 2 means the whole thing must times 2. So it's 6x minus 4y equals to 4. Alright, so that wraps up for this chapter. It's a bit long. I think it has been how many hours? 2 hours already, I think. 2 hours plus. So this is basically the chapter that I want to go through with you lah.